2020 ADMA paper 1, question 11. The curves y is equal to e to the power 3x and y is equal to e to the power 2 minus x intersect at the point B. Find the coordinates of B. So to find the coordinates of B, coordinate geometry tells us that we can simply solve the two equations simultaneously. So we have this and this. So now let's solve these two equations simultaneously. I'll use substitution method. So I'll substitute this in there that we have is equal to, and then since the bases are the same, so we can just say since this is equal to this, it means the powers must equally be the same, or else these two will not be the same. So we can say 3x will be equal to this. So you can take the 3x to the other side. Let's just add an x to both sides, and then this plus this will be 4x is equal to 2. Dividing both sides by 4, x will be a half. And then to find your y, you can use any of the two equations. I like picking the easiest, so I'll go for this. So y is equal to e to the power 3x. Your x is equal to a half. So that means y will be 3 over 2. So that means the coordinates of b will be a half, 3 over 2. And you are done. You don't, actually this is e to the power 3 over 2. You don't have to punch this on your calculator unless you want to. So when you do that, make sure you round your answer off correct to 3 significant figures unless you've been told otherwise. And then the gradient of each curve in terms of e. Okay, so in this case they specifically asked for the gradient in terms of e, so you have no choice but to do this. It's actually better at b. So remember, we have this word. A very common mistake is to find the gradient at this point and ignore this. So since one of the victims of that, I'll write them both so that I won't forget. So to find the gradient of this curve at b, we can just differentiate this curve. Dy dx will be equal to, when you differentiate the power, you get a 3, then write this thing as it is, like this. So the gradient at b, remember that at b, x is equal to a half. We found this, we found it here. So x is equal to half. So we can say 3e to the power 3 and then half. So that means we have 3e to the power 3 over 2, and you are done. This is the gradient for this. Then we can do the same thing here. Actually, you can even write this using the square root. So let's differentiate this. Dy dx will be, when you differentiate the power, you get -1. And then you write this thing exactly as it is. So you have negative e to the power 2 minus x as our dy dx. But since we want to find the gradient at b, we can get the x coordinates when x is equal to a half. So we have negative e 2 minus half. So this will be negative e. 2 times 2 is 4, minus this, minus 1 we have 3 over 2. So this is our second gradient. Then we are done with part A. On part B, we have this one here. When log 10 of y is plotted against x, a straight line is obtained passing through the point 0.6, 0.3 and 1.1, 0.2. Find log 10 of y in terms of x. So in this case, this is technically just a y, and then this is still an x. So all you have to do is to find the equation passing through this, and then replace your y with that. So let's find the equation passing through this. In a case like this, I like using this method. You are free to use any method of your choice. Y2 minus y1, then x2 minus x1. So I'll call these ones my ones, x comma y, so these will be ones, then x comma y, and then these will be twos. So we have y minus, my y1 is 0.3, my x1 is 0.6, then y2 is 0.2 minus y1, which is 0.3, and then my x2 is 1.1 minus my x1, which is 0.6, and then we have this equation here. So when you subtract this, you get negative 0.1. You subtract this, you get 0.5, and then we can simplify this. So this will simply be negative 1 over 5 when you multiply it by 1 over 5. Just trying to minimize fractions as much as possible. So now let's cross multiply. This times this will be 5y minus, let me just write it like this first. And then negative 1 times x minus 0.6. So let's expand. Negative x plus 0.6. And then we can take everything to the other side. Our aim here is to make y the subject of the formula and take advantage of the fact that this part here is actually the y. It's acting like a y, so to say. Negative x plus 0.6 plus 1.5. And then we have 5y is equal to negative x. This plus this, we have 2.1. And then now you can divide through by 5. And since we had decimals, it's okay to write this as negative 0.2x, since this is 1 over 2. Then this one will be 5 into that is 0. And then 5 into 21, that's 4. 5 into 10, you have a 2. So now this y here is log 10 of y. Since we were told that when log 10 of y is plotted against x, so this one is like our y. So you can, instead of having this, you can just say therefore, the equation we are looking for is log e of y, which is equal to negative 0.2x plus 0.42, and you're done.